This is a direct energy earth-linked copper refrigerant loop geothermal heat pump system, and it consists of several components. The first component is the copper loop that goes down into the ground. These loops are typically drilled into a 75 to 100 millimetre diameter borehole. The loops come in a 30-metre coil. They're uncoiled and fed down into the ground and grouted into those holes with a thermally conductive plasticized cement, which allows thermal conductivity between the refrigerant inside the copper loop through the grout into the ground and vice versa. These systems are reverse cyclable. They can heat and cool and provide a very, very wide array of different applications. The system that we're looking at here is designed to demonstrate reverse cycle ducted heating and cooling, and also domestic water heating or water heating for hydronic floors or radiant wall panels. The water side of these systems could also be reversed where there are water chilling applications. The heat pump itself, this is a 10.5 kilowatt heat pump. Here in Victoria, we get 3.5 kilowatts of thermal productivity for each 30-metre ground loop that we put into the ground. And that enables us to have very, very, very efficient heating and cooling processes, with the ground doing a lot of the condensing or evaporating of the refrigerant for us with no electricity or utility cost. And we'll demonstrate for you the ground loop system here in a moment. The heat pump itself will operate with very, very minimal amount of electricity, enabling us to save greatly on the utility cost for space heating and cooling and water heating or cooling. This is our hydronic or domestic water module, and it consists of a circulating pump that circulates water between our buffer tank or our tank that allows us to bring water up to an appropriate temperature. It also consists of a brazed plate heat exchanger, which allows us to transfer very, very, very economically heat produced by the heat pump into water or cold energy for water cooling applications. These heat pumps will operate as much as 80% more efficiently than conventional technologies for heating water for domestic and commercial applications. Very, very, very economical to run, and they provide very, very, very high degrees of heat exchange through the brazed plate heat exchange process. With respect to the air handling side of the geothermal heat pumps, it's actually no different to any conventional air handling management system. We use exactly the same fan coil units and air delivery systems that are used commonly in residential and commercial applications throughout Australia, and with a very, very minor modification, most conventional technologies can be adapted to be linked up to a ground sourced heat pump or a geothermal heating and cooling system. The heat pumps themselves, as you can tell, are very, very quiet. They operate with very, very, very minimal noise, and they also don't need to be ventilated, so they can be designed by engineers and architects to be incorporated into the building design rather than being external additions to the property. So there's some flexibility and some additional benefits on top of the extremely high energy efficiency in running these systems. There are a number of patented components within the heat pump itself, but the majority of the refrigeration technology in here is very, very basic and been around for a long, long time. Very, very reliable system. There are very few moving parts and things that can go wrong. So service and maintenance is reduced compared to some of the technologies that are available today. The compressor itself obviously is what's driving the refrigerant through the system in its startup phase. And once the refrigerant's up to velocity, it's actually travelling through the earth loop component under its own velocity, and ensuring that oil's migrating back to the compressor for the compression system to operate effectively. The refrigerant control processes in the earth-linked heat pumps are unique and incredibly efficient. They do a very, very, very good job for both heating and cooling applications. The ground portion of our heat pumps is very, very robust and very, very stable in the ground. As you can see here, this is a 3-loop system, so there are a pair of 3-loop manifolds that are enabling each of the 3 30-metre loops to provide heating and cooling capacity to the geothermal heat pump system. The ground loops are very, very stable. If we're in ground where there is a high acidic content or perhaps saline soil where there may be concern that over time the copper could be affected, we can engage a cathodic protection system that will allow an 80-year protection cycle for the in-ground copper portion of the system.